Hi, I'm Carly McAvoy. I'm showing you what the prerequisite knowledge is for the buried treasure activity. You might be doing this as part of a 101 class or a 107 class, but this one you're going to have to do several things with different measurement tools. First of which have to know how to read a ruler for English and metric units, and you're going to need one of those to do the activity. So if I'm looking at something here, I can count the number of lines that there are in between the 0 and the 1 inch. 1, 2, 3, 4, 5, 6, 7, 8 to the halfway point, which means we have 16 marks, and that means we have a precision of 1/16. So we can measure things to the 16ths here. If I ask you to measure a line that was 2 and 3/32, you would not have a precise enough tool for that. If you wanted to know something like right here, what's the length of a line that ends right here, we would say there's 2 inches, and then 1, 2, 3, 4, 5, 6 sixteenths. It's kind of not exactly on that, but you're going to have to go to the nearest 16th here. So that looks like 2 and 6 sixteenths, which we would then reduce. I'm not going to say approximately, we're going to say it's equal to 2 and 3/8, because we're going to divide both of those by 2 and get 2 and 3/8. So if I ask you to draw something that was 2 and 3/8 inches long, you could do that easily. Or if I ask you to measure something, you could do that as well. So be prepared for either one of those. I flipped this particular ruler upside down so we could then see also the millimeters and centimeters. Now each of these numbers represents a centimeter. You can see that a centimeter is not as long as an inch if you look straight down or straight up. It's 2.54 of these to make an inch. But in between each of these is 10 marks, and those are millimeters. So you could measure in millimeters or you could measure in centimeters using this, and you should be able to also measure that. If I wanted 2.3 centimeters, you'd go to 2 and then 3 more, and there'd be 2.3 centimeters, right? So be prepared to use your rulers. And then you also need to know how to use a protractor. So a protractor you use for measuring an angle, and you see this point right here. This should be placed on your vertex of your angle, and this line should go along one side of your angle. That ray that makes one side of your angle should be along this line right here. And then let's say we put it on an angle like that, and then we had this come up like this. And then we'd say, okay, well, from here, which is 0, we're going to go up to this. Now notice this right here, it says 50. It also says 130. If you were starting from this side, and you had you'd have a 130-degree angle, but we're starting over here, and so it's smaller. Remember that straight up would be 90 degrees. So if you have an angle that looks like definitely less than 90 degrees, it can't be 130, it's going to be 50. But the two different markings are on there because depending on where your angle is starting from. So from here though, straight up, that looks like 50 degrees. So that would be a 50-degree angle. Remember, you want to start your vertex here and you want to have the side on here. So it's kind of hard to show you on this video to have enough space. But let's say that I had an angle, and I'm going to make it pretty big for our purposes so we can use that. Let's say that I have this angle, and I want to measure that angle. And what I want to do is take my protractor and I want to put that circle right on the vertex of my angle. And then I want to make sure that this line is on my angle right here like that, which it looks like it is now. And then, oh my gosh, I drew another 50-degree angle, because from here I can go up and again it's 50 degrees. Okay, and that's pretty amazing that I drew two 50-degree angles just random. But they're not all 50 degrees. And if I had an angle, let's say I had the same side over here, but I drew this angle, let's say this angle, then I still would put this here and I would put that here. But now that I've gone from here, I'm going past 90. And so now when I look over here, I'm at the 130 mark, or at least it looks maybe like 128. You can see that there's little marks in between. I'm really stuck on 50 and 130 today. But that's when I would say I know that I'm past 90, so now I'm going to 100, 110, 120, and almost to 130, maybe 128 degrees. So maybe this angle would be 128 degrees, whereas just this one right here was 50 degrees. All right, so you have to be able to measure angles given using a protractor, or to draw an angle. If I ask you to draw a, let's say I wanted you to draw a 32-degree angle, you could do that. You would start by making a line, and then to draw a 32-degree angle, you put your circle on that point, and you make sure that it's going along the line, and then you go 10, 20, 30, 1, 2, and there's your point that you're going to connect, and then you've drawn a 32-degree angle. All right, so you can draw an angle if you're given a measurement, or you can measure an angle, either way, using a protractor. Okay, moving on, you also need to be able to use a compass. Just so you know, a compass is this right here. It's hard to draw a compass on without covering up the camera with my hand under there. You can't see what I'm doing. But basically, when you're using a compass, this point should not be moving. It should be stable. And then you move the rest of it, you sweep around with your pencil. And you want to keep that point stable. And it is hard to watch me do it, but I think most of you have seen one of these or used one of these in the past. And the point is, you're not going to get a nice circle unless you keep your point stable. And you can even draw a little point if that helps you and say, I'm not going to move off of that. But you have to have a compass and know how to use a compass to do this. The rest of this is just terminology that you should have seen in the past, but it's all terms that show up in this activity, so I want to make sure that you understand what they mean. A square obviously has 4 equal sides. The perimeter is 4 times the side, and the area is side squared. That is, if we had the side called S. A line segment has 2 definite endpoints. A line segment AB would have this, and that means it's not a line that goes forever. It definitely stops and starts. So if I told you to draw a line segment that was 2 inches long, that means it definitely starts and stops and has 2 inches in the middle. Perpendicular lines form right angles or 90-degree angles. So if I say to draw perpendicular lines, you should have a 90-degree angle where they meet. Parallel lines are lines that never intersect. The vertex of a polygon, the point where the sides meet, so the vertices of this particular shape are A, B, C, and D. I don't know why those are being cut off, but these are the vertices, those points where the sides meet. The midpoint of something is the exact center of a line. So a 2-inch long line, this midpoint is 1 inch. It's half of that. Angles, the angle to the right could be named ABC. Again, I've kind of lost a little bit of that B and C. I think my text boxes must have been too small. ABC, or it could be CBA, or we could just call it angle B. See that little symbol right there just means angle. And right now, this angle is opening to the right. So I think in that activity, I say open to the right or open to the left or open down. Just means I'm saying which direction that your angle should look as you draw it. Complementary angles are angles that add up to 90 degrees. If you want more information about angles or any of these geometry terms, you can watch the videos that are in the geometry packet or geometry assignment. 90 degrees, 2 angles add up to 90 degrees if they're complementary. If they're supplementary, they're angles that add up to 180 degrees. For a circle, the formula for the circumference, that's the distance around, is 2 pi r, or diameter times pi. Those are the same because 2 times radius is the diameter. So you can have 2 radiuses or 1 diameter in that formula. And then area equals pi r squared. Radius is important here. We don't use diameter. You have to cut the diameter in half if you have diameter and then square it. A trapezoid is in your thing where you have to draw a trapezoid. So I want you to know that this has a big base and a little base, and it has the height in between. If you were looking for the perimeter, you would add all sides, the sides being here, not the dotted line. The height is part of the formula for the area, big base plus little base divided by 2 times h. So those formulas are going to be in there. And if you knew, well, I'll let you encounter that on your own. Another thing you might have to do is convert between centimeters and inches. And again, 1 inch is 2.54 centimeters. So if you had 17 inches, using unit measurement, you would say 17 inches, and then you'd say inches in centimeters. And 1 inch is 2.54 centimeters. And then you could just multiply. See how the inches are going to cancel? And you're going to multiply 17 times 2.54 and get 43.18 centimeters. Or if you had centimeters, you're going to get rid of centimeters by putting them on the bottom. You're going to end up with inches. Again, 1 inch, 2.54 centimeters. So in this case, your centimeters go, but you divide 15 by 2.54, and that gives you 5.9, rounding to the hundredths, 5.91. So we have 5.91 inches. So you'll have to be able to convert somewhere along the way between inches and centimeters in that activity. And then finally, if I ask you to find the fraction of something, that means to multiply. So if I ask you to find 1/3 of 8.5, that means 1/3 times 8.5. This word of, that implies multiply. And then that becomes 1/2 times 8, 1/3 times 8.5, and then 1/3 times 17 halves, because 8.5 is 8 times 2 is 16 plus 1 is 17. So that would, if I do think I asked you a few times to find something that's 2/3 of the way up or whatever. And so if I'm saying the word of, I am suggesting multiplication. All right, have a fantastic day, and we'll talk to you next time.